Alright, good day and welcome back to Everything Mathematics, and today we're going to be continuing our series on geometry, and today will be a part one of 3 videos actually, where we will look at the relationship of linear equations. And there are 3 specific relationships that we're going to look at, and thus the 3 parts. So we have part 1, part 2 and part 3. So objective. Today we of course will cover the first one, the first type of relationship, and that is identifying and finding when a linear equation is parallel. How can we tell that a linear equation is parallel, or how can we determine if 2 linear equations are parallel, whether from the formula or whether from a graphical standpoint? Of course, in the part 2, tomorrow God willing, we will look at identifying and finding perpendicular line equations, or when lines are perpendicular. And last but not least, we're going to look at how to identify and find concurrent linear equation. And don't get carried away with the word concurrent. It's another word for just intersecting. So when 2 lines are intersecting, how do we determine that, and how do we find that point of intersection? So let's go. Let's just do a quick thing on parallel lines. So basically, when we're talking geometry, or when we're talking on a coordinate plane, 2 lines will be said to be parallel so long as they have the same gradient. And that's all there is to that. So if I give you 2 linear equations, and by now we should know the general format of a linear equation. So for example, if I give you y is equal to mx plus c, and then we have another linear equation, let's say y1 is equal to mx1 plus c. If this gradient here is the same as this gradient down here, just like that, we say that these 2 lines are parallel. And by parallel, you know, we say that these 2 lines are running side by side, they're the same distance apart, and it no matter how long you stretch them, they would never meet. And here is just a keynote. So therefore, it's as simple as this. In short, if m1 is equal to m2, in both lines, or we say that, hold on, something missing here. m1 is equal to m2 in both linear equations, or yeah, something definitely missing here. So therefore, in short, if m1 is equal to m2 in both linear equations, then we say that this line is parallel, simply put. So let's see if we could get a little practicality out of this. So here we have a scenario. Show if the line y is equal to 3x plus 4 is parallel to the line running through the points 6, 4 and 3, 2. So what can we do here, or what should we do here? Remember, we have this equation here already. They gave us this equation here, so we know this equation. And of course, we have to be able to determine the gradient. So in this one equation here, in y is equal to 3x plus 4, we know that m is equal to 3. So this is the gradient of this given line here. The question, however, is they want us to find out, they want us to show rather, so that means it is. So we have to show that this line is parallel to the line running through the point 6, 4 and 3, 2. So all we need to do now is find the gradient of the line that is running through these 2 points. And we already know to find the gradient when given 2 points. We did that 2 days ago on Monday. So if you haven't seen that video, just go back and take a look. So to find the gradient when given 2 points, we do m is equal to y2 minus y1 divided by x2 minus x1. And let me just identify these values here. So let's use here as x1, and let's use here as y1, and let's use here as x2, and here would be y2. And if that's the case, the top now I have y1 minus y2, y2 minus y1. So that will be 2 minus y1, which is 4, and all that's divided by, nope, I see something happening here already. That will be, so if, oh, no. The question said, show if the line this is parallel to the line running through the point. So it's either it is or it's not, because from what I'm doing here, I could already see that it's not. Unless I make a mistake, let me see. y2 is 2, yes, according to what I wrote there, y2 is 2, and y1 is 4. Then x2 is 3, minus x1, which is 6. Yeah, this is definitely not the same as 3. So this is 2 minus 4. That should give me negative 2. And then I have 3 minus 6. That should give me negative 3. So my gradient here is 2/3. Close, but not. So then show if the line y is parallel to the line running through this. Is it parallel? No. So you have to state that. So you say the line, that is a lot of writing, so I will try to abbreviate. So the line y is equal to 3x plus 4 is not parallel. Is not parallel to blah 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 blah. You got the rest. So the line y is equal to 3x plus 4 is not parallel to the line running through the point 6, 4, 3, 2. Why not? Because when we get the gradient of the line running through the 2 points, we get 2/3. And for the line to be parallel, remember, m1 has to be equal to m2. So if that does not happen, then it's safe to say that the lines are not parallel. Easy does it. Let's try another question. Let's try this one. Oh, interesting. So in this one, we have 3 equations. They said which of these lines are parallel? And again, all we're looking for is to make sure that the gradients are the same. But notice in this equation, this thing is rather jumbled up. So when you're given a task like this, the first thing you try to do, or not try, but the first thing you should do, is write the equation in the form y is equal to mx plus c. You do this first for each one, and then we just try to identify the various gradients. And remember, they will be parallel so long as the gradients are the same. So let's play up with the first one. So we have a first. A was given as minus 4x equal to y plus 4. And I want this to be written in the form like this. So of course, to easily do that, you have to play around with, well, it's a little algebra here, but the essence is that you're making y the subject of the formula. So to do that, in this case here, all I do is send over the y over here, sorry, the 4x, the 4, so that the y will stay for itself. So that will leave me with y, well, let me write it the first way first. That will leave me with minus 4x minus 4 is equal to y. But let me just reshuffle it now. So this is the same as saying y is equal to minus 4x minus 4. Good. So now this here is much closer looking than this here, or like this here. So we have a y, we have a m, look at the m, we have a x, look at the x, and we have a c, right? So this is what we're trying to achieve now. Let's do the same thing for b now. Let me put b in a different color. So let's do the same thing for b. So initially they gave us b as 2y is equal to 4x minus 4. And this one is a lot closer to what we want it to look like, but notice that there's a 2 by the y, and that cannot work. So we just divide here by 2. And because we divide here by 2, we divide on the other side by 2 also. So that will leave us now with our y equal to 2x minus 2. So yeah, in this one we have to play around a little just to make sure we get what we want. So right, straight away here we could see at least that A and B are not parallel because the gradient of A, a matter of fact, let me state the gradients as I go. Notice that M here is equal to minus 4. Good. Notice that M here is equal to 2. So evidently, these two lines are not parallel. Let's see what happens with the third one. So for the third one, we have, that's C, we have 4 is equal to y plus 2x. Remember, it's all about the gradient. It's all about the gradient. Parallelism in a coordinate plane is all about the gradient, the equality of the gradient. So here now I want to get rid of the 2, getting rid of the 2. So I send the 2 on the other side. So I have 4, or by transposing, of course. So I just send over the 2 over here. So I have 4 minus 2x is equal to y. And let me just reshuffle this. This is the same as saying y is equal to minus 2x plus 4. Man, all these questions brutal, man. So m is equal to negative 2. None of these. So which of these lines are parallel? None. None. None of the lines. We don't even get one that work out to be parallel by. None of the lines are parallel. I actually took all these questions from the red textbook, red maths book. Caribbean students would know that. So none of the lines are parallel. Why? Because none of the gradients are the same. And you have to be careful here. I guess this one was a trick too, because some people might see negative 2 and then you see 2. But negative 2 and 2 are not the same. They're not the same. In fact, if you have a good understanding of this, 2 will run somewhere like this, but negative 2 will run somewhere like this. So this is a negative gradient, this is a positive gradient. So they're by no means the same line. Good? Well, unfortunately, we didn't get none today that proves to be perpendicular. Sorry, that proves to be parallel. But I trust you get the gist. For it to be parallel, basically, the gradients have to be equal. The gradients have to be the same. So, until then, as always, like, share, subscribe if you haven't as yet. Comment, turn on that notification bell. Feel free to like the video, of course, as I just said. And until then, you take care. Tomorrow, we're going to look at the next relationship, which would be perpendicular, or to determine when two lines are perpendicular on a Cartesian plane coordinates, geometry, coordinate, geometry, what is it? Coordinate geometry. So until then, you take care.